Alright, so greetings friends, and here's what I want to talk about today in scientific notation. Basically, it's a way scientists and other people use math to write really, really big numbers. And one of the things I want you to remember is um, if you have something like 10 to the first, it's equal to 10. If you have 10 squared, it's equal to 10 times 10, which is 100. 10 cubed equals 1,000, and we'll say 10 to the 6 equals a million, etc., etc., etc. So if I want to write 5 million, I'd have to say 5,000,000,000. Well, it's not a super efficient way of writing 5 million, especially if I had to write 5 million a lot. So what I could do is I could just say, well, that's really 5.0 times 10 to the 6, because 10 to the 6 is a million, and that really means 5 times a million, which is 5 million. And so if I wanted to write, let's just do another one, 6,000, I'm sorry, not 6,000. Let's say 6,034,000,000. Well, then to say 6.034 times 10, well, now I have 3, 6, 7, 8, 9 times 10 to the 9th. And the way scientific notation really works, so I'm going to get rid of this guy here, is this. Basically, you're going to take some number, a, you can multiply it by 10 to some power, but a is between 1, it could equal 1, but it's less than 10, and you'll notice that here I chose 5.0. Here I chose 6.034. Both of those are between 1 and 10. And so n is an integer. And if you're not sure what an integer is, think back to your integer number line. Most of your teachers probably have them someplace. And an integer is really just a whole number and its opposite. And its negatives, I should say. So like -4, -3, -2, -1, 0, 1, 2, 3, 4. These are all integers, and they go on indefinitely. So let's do one more quick example. And what if I had something like this? 1, 0, 0, 0, 0, 0, 0. I'll put another 0 here. So let's see. If I need to make this between a number between 1 and 10, it can equal 1, because this means it's less than or equal to, but it cannot equal 10. So it has to be 1.0 times 10, and now we're going to count. Ready? 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. And this number is 10 million. Alright, that's how you write really big numbers in scientific notation. Just in case you were wondering, if I had something like this, 3.25 times 10 to the 4th, all I would do is, and I would use pencil, and take a look, I even have a little pencil font button up here, and say, well, I need 4 spots. 1, 2, 3, 4, and I fill in my little egg holders, if you want to call them that, and I get rid of my pencil drawing. And what do I have left? I have 32,500. That makes sense because 10 to the 4th is 10,000. So 3 times 10,000 is 30,000. So 3.25 is 32,500. Alright, there is one last thing. And I'm going to erase this. And the last thing I want to show you is, those are all fairly large numbers. I'm going to show you something else. You can actually have really small numbers. We have numbers like this, 0.000104. And once again, I need to write some number between 1 and 10. So I'm going to pick this. I'm going to make it as 1.04 times 10. Now, I'm going to the right. I'm moving my decimal to the right. So it's going to be 1, 2, 3, 4. Do that in a nice purple color. 1, 2, 3. Oh, that color is lovely. 4, but it's backwards, so it's 1.04 times 10 to the negative 4th. If I had 2.15 times 10 to the negative 6, I'd say 0 point. I'd say 1, 2, 3, 4, 5. And now my sixth one will be the 2, 1, 5. And sure enough, if you count, I'm a little hesitant to even leave this purple color because it's so nice. 1, 2, 3, 4, 5, 6. And that's where you'd make that number 2.15. I'm going to get rid of those. That's it. And so that's pretty much it for scientific notation, writing numbers really big or writing numbers really small. And I hope that was useful.